Hello everyone. So hope you are doing good. So I am preparing this video basically to help you. So if you have any suggestion or comment, just go for it, and your suggestion and comment will be help me to improve, because you are the knowledge seeker. So what is your interest and how you want to learn, it depends on you, not on me. So let me know which type of thing you really want and what type of elaboration is really help you, and it will be really helpful for me also to manage the videos and to make them according to your uh, necessities. Okay, because you are the one who is observing this. Okay, thank you, and thank you for watching again. Go again. So if we consider that we have three different type of elements, if you consider some of them 1, 2 or 3 electron in their outermost shell. Some of them have like 4, 5, 6, 7 number of electron. We keep 4 in between, okay? And some of them have 8 electron in their outermost shell. So who are the 8 electron? 8 electron are the inert gases, okay? Now for the inert gases, only for helium, okay? Only if you consider about only helium, then it is 2. Rest others, it is only for helium. Others 8. Now, due to this electronic configuration in the outermost shell, we believe that each and every inert gas is really stable than other elements. Now, if you have someone, if you know someone who is really stable, who is not have any interest with anything like any type of earthly things, worldly things or anything, he is just doing his job, he is satisfied whatever he have, he is not with in a quarrel with other, he has no interaction with others. Now if you consider this type of thing, then each and every element has the tendency to attain this type of status. Now to attaining this type of status, they always have the tendency to convert to 8. They always also have the tendency to convert to 8. Like hydrogen and nearest elements, they have the tendency to convert it to 2. If without that, all of them has the tendency to convert it to 8. Now there is two ways of obtaining 8. Those who have 1, 2 or 3 electron, they can donate it, and this donated electron can be accepted by these elements. So by accepting 1 electron it will be 8, accepting 2 electron it will be 8, accepting 3 electron it will be 8, all of them are 8. So this is one of the way. That means someone will donate and someone will accept. Now those who donate, they are known as metals. Those who accept, they are known as non-metals. That means these are the non-metals and these are the metals. Now when a non-metal and metal try to get bonded with each other, then the metal always donate electron and the non-metal always accept electron. By donating the electron, if anyone donates, he become positive. So that means if anyone donate, like if sodium donate 1 electron, okay, then sodium converted to sodium ion plus electron. This electron will be accepted by a chlorine atom and it converted to negative ion. Now this ion is known as cation. That means when any metallic atom donate any electron and then it becomes a positive ion, then it is known as cation. And that electron, if accepted by any non-metal and it becomes a negative ion, then this is known as anion. Okay. Now this anion and this cation, if you look at, one is positively charged, another one is negatively charged. Okay, we know same charge always attract each other and opposite charge always repulse each other. Now, if these two charges come closer together, then they will feel a electrostatic force of attraction. Electrostatic force of attraction. Okay, and due to this electrostatic force of attraction, they combine together to form sodium and chloride. And this compound, the compound which is formed in this way due to formation of the cation and anion, is known as ionic compound because it is formed by ions. Now, the bond which is formed between these two elements to attain the octet is known as ionic bond because they form the ion and then go for the bonding. So this bond is known as ionic bond. In other way, we can say the bonding which form due to formation of a cation and anion in between two metal and non-metal is known as ionic bond. Okay, now we will see what happened to their electron if they donate or electron accept. Okay, now we say that sodium, it has 11 electron, 1s2, 2s2, 2p6, 3s1, and chlorine, it has 1s2, 2s2, 2p6, 3s2, 3p5, 17 electron. Now, when sodium donate this electron, then this electron is no more to the sodium. So sodium has octet structure which is equivalent to the neon 10, which is a really stable structure. And then it converted to Na plus, and when chlorine accept this electron, it become plus 1. Now when it become plus 1, then it has the electronic configuration of the argon 18, which make it Cl minus. 1 electron accept, so 1 chloride. 1 electron donate, so 1. Okay, so that means by bonding with each other as a sodium chloride, allow our sodium and chlorine to attain the electronic configuration of neon and argon respectively. And due to this process, they also have the electronic configuration of octet. They fulfill the octet rule and they are stable. So to stabilize themselves, they go for this type of ionic bond. Any metal wish to contact with any non-metal, then it go for this rule, and this is called ionic bond. And now ionic bonds, as they have the ion, so you can say there is a sodium and chloride ion. Okay, as they have the ion, so they are polar because they have certain pole. Okay, positive side and negative side, so they are polar. They are definitely polar. They have high melting point and boiling point. They are brittle. If you give any pressure, it will break down. So when you read the crystallography, you will see that the metal ion and non-metal ion highly close packed. Now if we press little bit, then it will just break down easily because it is brittle, or because it is the ion is separated in their position, and if one ion separated, then total lattice structure is changed, so it is break down. You will read in crystallography. Now, and also they have some of the ionic compound have a lower melting point. I said they are high melting point and high boiling point, but some of them, like if we prepare a metallic a positive ion with this size and a negative ion with this size, or a negative ion with this size and positive ion with this size, due to size of the very high large size of the cation or anion, some of the ionic compound remain liquid in room temperature. They are known as ionic liquids. They are known as ionic liquids. Except them, almost all of the ionic compounds has very high melting point and boiling point. Now, again, so this is goes for the non-metal and metallic bond. Okay. Now, if non-metal and non-metal want to bond with each other, then what will happen? Okay. Now, suppose if we consider, suppose hydrogen has 1 electron, chlorine has 17 electron. Now, chlorine has 7 electron in its outermost shell, or hydrogen has 1 electron in its outermost shell. Hydrogen cannot donate an electron. Again, chlorine cannot donate an electron. Then, or again, if we consider about oxygen 16, okay, sorry, oxygen 6, carbon, oxygen 8. Oxygen has 6 electron in its outermost shell. Now, none of them basically, or nitrogen, if we consider 5 electron in its outermost shell, none of them are ready to donate an electron, because everyone is deficient. If you are deficient of money, then you will try to find out more money. Okay, hope it will be in good way, not the bad way. Okay, so you will try to find out the money. Now, each of them are actually electron. They are non-metal. They have too much interest with the electron, and also they are very difficult for them to donate this amount of electron to attain 8. Okay, suppose if we consider about chlorine, then it is 1s2, 2s2, 2p6, 3s2, 3p5. Now, in chlorine, it has only 2 way. Any non-metal has 2 way. One, accept 1 electron or donate 7 electron. If it accepts 1 electron, then this configuration, it becomes argon. If it donates 7 electron, then this is become neon. So there is 2 way to obtain the electronic configuration of the inert gases for the non-metals. It is either it will donate 7 electron or it will accept 1 electron. Which one is easy? Accepting 1 electron. So they go for accepting in the ionic compound. Now, there is no metal. Then who will donate? Nobody will donate. Then they go for a mutual understanding. That okay, I need 1 electron, you need 1 electron, then let's come, we will share it together. So you will share my electron, I will share your electron, and then we will feel like that we both have 2 electrons, but we will not able to avail both the electron by ourselves. And now this type of sharing, mutual sharing, allow hydrogen to share its 1 electron with the 1 electron of chlorine, which has already 7 electron here. If this is the electron of the chlorine and this is the electron of the hydrogen, so they are actually sharing their electron. Okay, so this is the formation of hydrogen chloride. If we say hydrogen chloride gas, or if we can say hydrogen chloric acid, this is the formation methodology. So that means there could be some bonding in which we just share the electron. Okay, now sharing the electron will also give you another type of bond. Okay, so what is the name of this bond? This bond is covalent bond. Covalent bond. Okay, that means now what is the definition then? Now if two or more elements combine with each other to obtain the electronic configuration of the inert gases through sharing of the electron among themselves, not the donation, sharing of the electron among themselves, then those bonding is known as covalent bond. Okay, that means ionic bond always metal non-metal and covalent bond between two non-metal. Okay, covalent bond is between two non-metal. Now there is some special criteria of the covalent bonds. I will discuss them gradually one by one. One thing, we said that in covalent bond electrons are shared. Okay, now if the electron is shared, or suppose if you think hydrogen share one electron and chlorine share one electron and they form hydrogen chloride, or we can write HCl. Now this shared electron should be in between two nucleus. The distance from hydrogen and distance from chlorine nucleus should be same for the sharing electron, because they are sharing. Okay, we go for sharing with equal contribution, then it should be like that in the center position. But problem is that if they have very high energy, if they have very high fascination, if they have very high fascination towards electron, then they are basically pull the electron towards themselves, which we call the electronegativity. If the electronegativity is higher, then this element always pull the electron towards itself, and basically the result becomes like that. So it should be like that, but it becomes like that. Okay, so this is called partially positive, this is called partially negative, and this type of covalent compounds are known as polar covalent compounds. Okay, this is known as polar covalent compounds. So the polar covalent compounds are like that. Now there are some covalent compounds like carbon and hydrogen. Okay, in this covalent bond they never bother the electron to one another, so they're not they're not like so you can remember some of your friends when you go to your class in when you was in maybe elementary school or something like that, then they snatch your breakfast and they eat it because they was too much fascinated towards your breakfast. Now in this case he is doing that. If he do that, then they are negative, but they are not like that. They are very gentle, they keep their electron in between them, so they have no problem. So this is called non-polar. Okay, so this is polar covalent compound and this is non-polar covalent compound. So therefore covalent compound are two types. One which has a partial pole similar to the ionic compound. Ionic compound has the completely separated pole, but they have partial pole which has the ability to attract the ionic compound also, and all the ionic compound basically dissolve in the polar solvents. But non-polar compound, they do not have any pole, they are just sharing their electron and like that. Okay, so there is then two type of covalent compound. One is polar covalent compound, another one is non-polar covalent compound. Now for polar covalent compound, they always has the ability to dissolve any ionic compound if they are soluble in the polar solvents. Like water is a polar solvent. Okay, hydrogen chloride is a polar. Now in case of non-polar, it is not possible. Again, if we look, so this is go on the polar covalent compound and non-polar covalent compound. So there is another covalent bond. There is two type of covalent bond if we consider covalent bonds. One is sigma, another one is pi. So one is sigma, another one is pi. Okay, sigma covalent bond and pi covalent. Now what is sigma bond? We know the orbit. We said the orbitals. You can remember we say the orbitals. This is like px. This is s. Okay. This is d. Okay. Now these orbital actually take part in this sharing process. Now if a orbital share with another orbital or overlap with another orbital in front direction, that means head to head, then or like that, this is also a head to head, or like that, this is also a head to head. Now this type of bonding with another orbital, if one orbital bond with another orbital in such a way that they overlap in head to head position, then this is known as sigma bonding. Now all s orbital always form the sigma. S orbital always form sigma. That means if s orbital form bond between s orbital, then it is sigma. If s with p, then it is also sigma. But in case of p, it has 2 degrees freedom. Okay, it has the ability to overlap in this direction, or it has the ability to overlap side by side, like they can also overlap like that. Okay, they can also overlap like that. Now this type of overlapping is known as pi bonding. So that means there is 2 different type of covalent bond. One is sigma bond, another one is pi bond. Now in between 2 atom, if there is 2 atom, any 2 atom, okay, if there is any 2 atom, and they are trying to bond with each other, okay, that means if chlorine want to bond with hydrogen, if carbon want to bond with hydrogen, if nitrogen want to bond with oxygen, then there must be one sigma bond, and then the rest of the bond are pi. How? Like chlorine bonded with by one bond, then it is sigma bond. Carbon bonded with hydrogen by one bond, it is sigma bond also. Nitrogen bonded with oxygen with 2 bonds, then one is sigma and another one is pi. Again, in case of carbon-carbon double bond, in these 2 bonds, one is pi, one is sigma. In case of carbon-carbon triple bond, one is sigma and 2 is pi. So that means in between 2 atom, it is impossible to form 2 sigma bond. It is always form only 1 sigma bond. Okay. Now, if we consider that if your sigma bond and the pi bond, okay. Now, if we consider that how many sigma bond is there, so you can calculate. I said single bond means sigma, okay. This single bond sigma, and then this triple bond 1 sigma and 2 pi. So that means there is 3 sigma and 2 pi bond. Okay, I think it is clear. Now we will go for hybridization. Hybridization, I said it hotspots. Just making hotspots using some orbital. Okay. So if we consider about carbon, like carbon 1s2, 2s2, 2p4, okay, 1s2, 2s2, 2p2. Now these 2 basically give carbon the valency 4. Now there are two different basic orbital. Okay, if 2s is here, then 2p should be a little bit higher. 2px, 2py, 2pz, because this is higher energy than this one. Now, when carbon tries to form the bond, sigma bond, then basically they always mix up with each other to form equal energy or energy containing orbital. They have different orbital. They mix up with each other to form four different similar energy orbital. They are known as hybrid orbital. Okay, they are known as hybrid orbital, and they are the normal orbital. Now this hybridization could be in different way. It could be 1s and 1p, it could be 1s and 2p, it could be 1s and 3p. Now depending on which type of bonding, which type of style they are going, we can say this sp hybridization, sp2 hybridization, sp3 hybridization. That means 1s and 1p, 1s and 2p, 1s and 3p. Now there is two orbital participate into the hybridization, then there will be two hybrid orbital, and there will be three hybrid orbital, and there will be four hybrid orbital. Okay, now if we consider this hybridization with respect to our compound of the carbon, like in case of methane, the hybridization is 4, sp3. Okay, sp3. That means there will be 4 hybrid orbital. So 4 equal energy hybrid orbital. Okay, and then these 4 combine with 4 hydrogen through the sigma bond. And another one thing, just remember, hybridized orbital only form the sigma bond. Hybridized orbital only form the sigma bond. So then this is CH4 methane, and all of them are sigma bond. Now for sp2, that means we have 3 different hybrid orbital. So if it is 3, like these 3, so that means there will be 3 different sigma bond. Now who is sp2 hybridized? sp2 hybridization is carbon-carbon double bond. Now if we look at carbon-carbon double bond, so that means there will be 2 carbon. This is one of the hybrid orbital, this is another hybrid orbital. They form a, now it has another 2 hybrid orbital left. It has also 2 hybrid orbital left. Okay, so these 2 hybrid orbital bind with 2 hydrogen. These 2 also bind with 2 hydrogen. Now, but the one of the p orbital is left, because from this 2p it is only 2p. That means there is another one is left. This is non-hybrid p orbital. So each bind with each other to form a pi bond. So there is sigma, 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 and only one pi. So this is called sp2 hybrid orbital as a result, because 1, 2 and 3 p electron, so 2p and 1s, so total 3 orbital combine together to form the hybrid orbital, and 1p remain unused. Now the rest one is the rest one is the sp. Now if it is sp, then only one s and one p, that means 2p, 3p is already, you have 2p left. Okay, now if we consider this carbon and carbon, so they have only 2 hybrid orbital. Okay, they have only 2 hybrid orbital. So this is carbon carbon sigma bond, and this is with one hydrogen. Okay, so it is like that. We always write, this is our common one, we know. So then it has this pi, this pi, this p and this p. So this 2p orbital is basically empty, is not bonding with anyone. Okay, so if it is not bonding with anyone, then they will go for pi bonding. Okay, so there is 2 pi, 1 sigma, 1 sigma, 1 sigma, so 3 sigma and 2 pi bond. Okay, this is basically tells us the sigma and pi bonding. So the covalent compounds has two different type of covalent bond. One is sigma bond, another is pi bond. If it is hybrid orbital, then it is sigma bond always. If it is non-hybrid orbital, then they go for the pi bond. Now whatever the sigma or pi bond, if the electronegativity difference is very high, then they will form the polar covalent compound. If the electronegativity difference is low, then they will form the non-polar covalent compound. Who is the polar covalent compound? Simple example, water. Who is the non-polar covalent compound? Simple example, methane, which is you burn in your stove. Okay, so that's it. So this is basically you need to try again and again, and it is very simple, and I hope it will help you to understand the chemical bonding, and especially ionic bond and covalent bond, which I discussed. Now next time we will discuss about the coordinate bond and the naming of the coordinate compounds. Thank you very much. Have a good day.